All right, welcome. This is TRiRODS for February. What year are we in? 2023 somehow. Today we've got Kory Draughn from here in the iRODS Consortium. He's going to talk about GenQuery2, a richer query interface into the iRODS namespace. He's been working on this for about a year now, I think, after picking it up from others.
That's right. Thanks, Terrell. All right, let's get into it. All right, so to start off, what exactly is GenQuery? Basically, it's an SQL-like syntax provided by the iRODS system. It allows users to query the catalog for various information without needing to know the actual table joins and involved with doing that. So basically, it's excluding the from clause and various other SQL clauses that make things complex or harder to interact with an iRODS catalog. One of the other primary goals or features of the GenQuery syntax is that it also enforces the iRODS permission model. All right, so a bit about GenQuery1 and basically the limitations surrounding that. If you were to go and do a quick search in the GitHub issues for iRODS, you would notice several GenQuery1 related issues. Here I have a list of some of the most, I guess you can say, the highest rated issues, I guess. So this is not an exhaustive list, but for the most part, one of the features that people really would like is to be able to have support for logical or and not. They also want support for grouping conditions via parentheses. One of the things that's kind of challenging or really challenging with GenQuery1 is the fact that it's very hard to change, or that the code is kind of brittle. And so we're very hesitant around making changes to it unless they're pretty simple, because we don't want to risk breaking existing deployments and things like that. Another limitation of GenQuery1 is that metadata queries also receive special treatment when they are part of the condition clause. And so this means by special treatment, what I really mean is that there's secret grouping that happens behind the scenes that you don't know about unless you're really in tune with the GenQuery internals. And so, we want to get rid of the magic behind all these things and expose these things to the user so they have more control. Last but not least, another big item is that it can't handle embedded apostrophes and possibly other special characters. So before we get into GenQuery2, exactly like the specifics of it, I just want to basically go over a brief history about the project or the work behind GenQuery2. And that the first implementation was basically written by Ben Keller. And by this implementation's goal was basically to use better parsing tools and libraries that allow us to basically erase or handle all of the cases around like GenQuery1, so that basically we don't have to worry about writing our own parser and getting into the same situation that we're in today. The next person who picked it up was Jason Kapowski. He was the previous executive director, and he picked it up back in 2020 and worked on that a bit more, and actually he got it to a point where it was working with the database as far as like basically providing the implementation that re-implements many of the features seen in GenQuery1. And now I picked up the project in 2022, and we've set off into a new direction, whereas that we aren't necessarily trying to re-implement GenQuery1, but provide a brand new implementation with different features and goals than what we have today. So what are those goals for GenQuery2? For one, we want to provide syntax that's closer to standard SQL. SQL is a widely supported language amongst databases, and it's used by several people, companies, and places all over the world. And so if we can be closer in syntax to SQL as much as possible, then it's easy for people to just jump in and start using GenQuery without any hesitation. Aside from that, we also want to provide better support for logical operators such as logical and, or, and not, as well as support for parentheses so that users can, construct more complicated queries. Another thing that we're setting out to do is to allow people to provide basically mixed metadata-based queries. So instead of, one of the limitations with GenQuery1 was that you were not allowed to basically query metadata for data objects, collections, resources, users in one query. You had to do this separately. And so one of the goals with GenQuery2 is to lift that restriction and allow you to do this, because if you can write SQL, then you can do this exact thing. And last but not least, probably the most important goal is that we want the implementation to be easy to understand, maintain, and enhance. Again, I want to reiterate that this is not a re-implementation of GenQuery1. This is a brand new, basically, direction with GenQuery. All right, so how do we satisfy these goals? So first, we need to use proven tools. And that means, in particular, parsing libraries and facilities like that. The ones highlighted here, Flex and Bison, are the ones we're continuing to use. These were the tools chosen back when Ben Keller picked it up or started this. And we're going to continue to use these in GenQuery2 unless something else happens that, seems to make a lot of sense for us to move to. But just to give you a little bit of idea about what these tools are, Flex is a tool for generating scanners, basically performing lexical analysis. It scans characters and produces tokens. And then Bison is basically a tool for generating parsers. And so you can use these tools together to basically build abstract syntax trees or whatever you want as far as like compilers, interpreters, whatever. Another thing that we wanted to leverage is that we want to use the Boost Graph library. We'll refer to this as BGL. That's a pretty common convention in C++. And so with Boost Graph, the Boost Graph library, basically this is going to be used to represent and capture the database tables, relationships between each other. All right, so our first approach, our first attempt at doing this was we wanted to see if we could use Boost Graph or BGL's predefined algorithms to derive a path that connects all the tables that have been derived from the query. We chose to try and do this through a breadth first search algorithm while also using a predecessor map, these are both facilities provided by BGL. So the pros with this is that the paths are computed, the path between the source table and all other tables are computed just through a few lines of code. So it's very simple, straightforward, basically copy and paste. But the cons around this is that the BGL's implementations do not expose all possible paths from a source table to all other tables. And so we did not know if there were better routes between some source table and various other tables. It also didn't lend itself to supporting joining of the same table multiple times, which is important when you're trying to do things like support metadata queries across different entities within iRODS. So we proceeded with trying a different approach. This next approach basically is kind of going down the same path, but with the idea that we continue to use BGL's basically data types and containers, but instead we will provide our own custom breadth first search implementation, which exposes all paths between a source table and all the other tables. And we were successful in that. The pros around this is that it provides access to all paths, as I just stated, and it allows us to filter these paths based on whatever criteria we deem necessary. The downside to this is that it's complicated, way more complicated. The Boost Graph library is a very complicated, in my opinion, library to use. You can definitely tell and get a sense that it is tailored for people who have a background in graph theory. And so that's already a major X against this approach right here. But another thing, just like with approach number one, is that it doesn't support joining the same table multiple times. Trying to do that would require us to design data types which contain a lot of contextual information to determine later on whether we can make these joins possible. And that seemed to be a very bad way to move forward. And so again, we took another approach. So approach number three is that let's just leverage the BGL library for simply representing the database schema and relationships between tables. So that's basically just joins and having, basically we use BGL to provide some convenient access or methods around the database relations. And from there, we would just basically look at the set of tokens that were received through Flex and Bison and make decisions based on like whether we identified a column as special or whether we can just do a simple lookup and apply the necessary SQL. The pros with this is that it's extremely simple and straightforward. There's everything in the implementation is very easy to follow and understand. It also avoids the need for any knowledge around complicated graph theory. And so with this approach, it's shown so far that this was the right approach, at least for now. Okay. So now with that said, we'll get into a few demos. The first one here is basically a demo that basically lists all data objects having a metadata attribute name of foo and a parent collection having a metadata attribute of bar. And so I'm going to.
And this was hard before because we couldn't do metadata queries against different types in the database.
That's right.
Okay.
That's right. So let's show the first demo. All right. So first up, basically this first step is us creating a space for our demo. So we can create some data objects and collections. See here, we've created two collections with a data object inside of them. And now we're going to attach some metadata. So here you can see we have our metadata, whereas that we have a collection with bar attached to it. And then we have a data object here that has the attribute name of foo. We look here, here's our query, which was just run and which satisfies the conditions where it's that we're listing a data object in a parent collection based on whether the necessary attribute name and metadata attribute value are seen.
So you're running iQuery, which is not a thing that most people have.
That's right. This is a special I command that basically uses the new parser API plugin to run GenQuery-like, run the new GenQuery syntax, right? And so we can look at our query here. This is normal. I think everybody recognizes this, these columns, but in particular, the thing that of interest here is the metadata attribute name we have here is equal to foo, and metadata column attribute value is equal to bar.
Collection. Yeah, collection.
Meta collection attribute value is equal to bar. So already you can see the benefits around, this doesn't require multiple queries, it's just a single query, and we got the necessary row from the database that satisfies this. Right. So moving on to our next example.
Does that query assume that the collection is the parent of the data object? Is that an assumption that's made?
Yes, the
Okay.
collection name is
It's in the row.
yeah, it's in the row, the data object's parent collection. So the collection that hosts the data object. All right, so our second demo is basically a demo that basically is demonstrating sorting, basically I think, offset and limit capabilities. Here. Again, this demo is going to go through the necessary steps of setup and tear down. So we got our setup. There's our collections. It creates 3 collections. So it creates 3 collections and puts 3 data objects, A, B, and C, inside of those collections. And then we run, again, we use iQuery to run a GenQuery that basically orders the collection name in descending order. And at the same time, it orders or sorts the data name in ascending order. And notice that we've applied an offset to say skip the first one, the first entry, and only take 3 entries from the result set. So if we look here at this output, we can see that collection 3 would have been at the very top of the list because we sorted in descending order of collections. And then we said, use the data names within those collections to sort in ascending order. So you can see that explains why B comes before C. And because each collection only has 3 data objects in here, you can clearly see that we run into seeing collection 2 being listed as the next available collection.
So without the offset and the limit, you would have had 9 results. But you skipped the first A, and then you only printed 3.
That's right.
And so GenQuery 1 doesn't have that at all.
No.
Okay.
No, it can sort, but not
multiple.
right. All right. So our third demo here is basically a small demo of showing how you can basically showing the like operator. And so basically this demo is going to say, give me all the collections that have a prefix of collection or a suffix of .d. Here we create our space. And next up, we're going to create some collections and data objects. So you can see here, we have under demo 3, we have collection.d. We have a collection called collection. We have a collection called directory, order, source, and test. And then we proceed to list only the collections that have a prefix of collection or COL and or suffix of .d. Also in this query, you notice that we've also provided we've demonstrated support for parentheses in the sense that we want to only deal with collections that are under the demo 3 space, hence this one clause here. But the thing that we're most interested in is the usage of or and the like operators and parentheses. And so you can see that GenQuery2 provides full support for this type of thing. And there's no limit to the number of parentheses or how you group things. It's literally just going to pass it, it's going to parse it. And if it comes out acceptable to the GenQuery parser, then it will produce the necessary SQL and run that. And so here we see we got the right results.
And the call.d matched either one or both, I guess.
No, the call.d is matching the .d suffix.
But it's also matching the.
That's correct. That's correct. So really just whichever one the database decides.
But if you had a source.d, it would have come in, it would have shown up also.
That's right. Okay. All right. Our fourth demo is one where we are going to demonstrate, let's see. This is a demo that demonstrates logical not. So we create some resources. So you see we create some resources, then we use ILS REST to show that, hey, here's our resources. that's available in the system, and then we run a query that says, give us all the resource names of resources that are not part of this set here. So basically, we want all the resources that don't have a name of demo res, PT2, or REPL1. And if you look down here, none of those names appear in the list of resources, and it turns out to be the correct expectation. So not is also already supported in GenQuery2.
With the surprise of bundle rest making an appearance.
Right.
You did have a question from Paul in the chat.
There's a question.
Can you see it in the chat? Bottom of your screen.
Yes.
Yeah, I was just a little bit wondering about the naming of the database columns, which they are, so I suppose.
I'm sorry, can you repeat?
Yeah, so if you look here, not this one, but actually the previous one, that's what I was referring to. So here you say select call name,
Mhm.
and what you basically get back is the full paths to the collection.
That's right.
That is what's stored in the database for
Okay.
each data object. That's the way it's always been.
Yeah, right.
Yeah, it's not just the name of the parent collection directly.
Correct.
That's right.
Okay. I didn't know that.
Yeah, that's not a change. That's just
That's the way it is.
that's the way the database holds it right now. And I think that originally it was optimized for searching, because otherwise you'd have to build you have to daisy chain all the way back up and check all the parents.
Yes, that's what I do in our open search implementation.
That's right. That's right. So that was a design choice made a long time ago.
Mm-hmm. Okay. Yeah. Sorry.
Optimized
No
for searching.
worries.
Yep.
All right. So that was our last demo. So just now we're talking just a brief mention about paging with the new parser. So because the parser supports offset, limit, and fetch first in rows only, this means that you get implicitly the ability to do key set pagination, which is a technique that allows you to bypass the limitations and performance issues around using offset and limit. So this also means that we are pushing the responsibility of paging onto the client, because you have all of these additional options and ways to approach how you want to do paging for your application. But we are considering enforcing a default limit to protect the catalog from situations where they're dealing with result sets that range in the millions of records, right? Because we don't want people to exhaust their memory available to their servers and things like that. And so we are talking about how to deal with that situation. Okay, so for remaining work, there's still some things that we have to do before this is, production ready. That being, we need to apply and add support for permissions around data objects and collections. We also have to add support for various tables that aren't yet supported in GenQuery2. For example, the R-ticket allowed posts table. We need to finish adding support for microservices. We're also considering offloading queries and things that will probably be better served as specific queries. There's testing that we need to add, and also we need to improve the packaging around this project so that people can actually give it a try. All right, so future work. So some of the things that are some of our far-reaching goals that we want to, satisfy with GenQuery2 is being able to provide support for additional SQL keywords such as case, current time, timestamp, etc. We also want to provide support for sub-selects, the ability to concatenate columns via the double vertical bar operator. And we also want to provide support for multi-argument SQL functions, such as one saying like a substring, for instance. All right, so I think this is our last slide here, but community engagement. So the plan around GenQuery2 for now is to provide this as an experimental package / project, right? And so by doing this, this is us giving the community a way to participate in the direction of GenQuery2. That means that we really look forward to people giving us feedback on this and helping us to improve the implementation as far as features, things that aren't supported, things that should be supported, and just overall help us build a very good implementation of the next generation of GenQuery, right? Because eventually this will be absorbed by the server and just be readily available to everyone. This also gives us a chance to apply frequent updates because there's no ties to a specific server version or server release. So that's a good thing. Here you can see I provided the link to the GenQuery, to the official repository for GenQuery2. This at the moment is just an empty repository, but we hope within this week or the next to make the code available so that people can try it and start providing that feedback to us. And obviously, once this is stable enough and is absorbed by the server, this experimental package will, it will be obsolete at that point. And so you should remember to get rid of it if you do use it. And with that, thank you. And are there questions?
Yeah, go ahead.
For someone who doesn't know SQL that well, SQL that well, what is it about the multiple metadata type queries that necessitates joining onto the same table multiple times?
There are likely use cases where you have metadata attached to, let's say, to a collection, and you have metadata that you want to associate with data objects, right? And some of those to reach a particular goal, there may be situations where you need to check both, right? In GenQuery1, this requires running multiple queries to satisfy that kind of goal. But with GenQuery2, we'll remove that. Basically, under the covers, we're doing left joins so that we can join tables multiple times and return the results that will allow you to run a single query, hopefully boosting performance because decreasing the number of trips you need to make to the actual catalog. So not only is it a play on, giving people more capabilities or control, but it's also a play on performance, right? That's network, that's everything involved.
And
Yeah, that seemed like it would clearly be an advantage. You're right. I was asking mainly because the only SQL that I can imagine in which the same table is joined multiple times would be because of subqueries. Like what I imagine is your GenQuery2 formula, incantation boiling down to a complex SQL expression at the one that actually hits the database, right? And that would involve subqueries, and that's the only way I can imagine tables being hit more than once. Are you saying the left join is the other way of hitting tables more than once, or?
Yes. Normally, like even inner joins, right? Like, we could, the way iRODS handles joins today in a lot of cases is that these joins happen as a result, they happen in the condition clause, but kind of makes it difficult to figure out exactly what's the actual conditions we're interested in versus what's just join work, right? And so by using the explicit syntax of SQL table joins, we've now cleaned up the actual SQL itself and made it more digestible and understandable.
And that was also a thing that the Boost graph library couldn't handle, the generating of this kind of SQL that it did this kind of join within the condition clause. Is that true?
Well, you can think of the Boost graph library as just providing a way for us to
Represent
the database relations themselves in code, right? And so that means that it gives us the ability to query these data structures that say, hey, is there a link between these two tables? And if there is, what is the join? Well, to tell me what syntax I need for that link.
Okay.
I may have missed if this is a bullet, but is this fully backward compatible with GenQuery 1 as far as anything you could do in GenQuery 1 would return the same results?
No. So that is one of the things that, you know, I really wish I would have emphasized earlier, but the goal is that we don't want to stop ourselves from making forward progress on the parser itself by trying to provide backwards compatibility with GenQuery 1. Many of the queries that you can run in GenQuery 1 will work, but we are not going to carry forward things like how GenQuery 1 supports basically checking whether a single column matches two columns, for instance, right? You know, the equals double bar equals another thing type syntax. When really you could, by introducing or and providing parentheses, you get that for free, as well as several other enhancements and abilities.
Yeah, I'm not familiar with that syntax, but yeah, that makes sense.
Yeah, and we will go out of our way to document. One of the first things that Ben did actually was ran our entire test suite and gathered all queries that hit the system. And then the first thing he did was be able to tokenize all of those to make sure that we had capacity for that. And so we can do something similar and get a kind of a coverage, feel like where the differences are, and then we can talk about those in the documentation. But the other thing is to how do we incorporate this into the server eventually? You know, for a while, maybe we have a flag that lets you pick which parser you want to use. And then maybe eventually we deprecate the first one, and then eventually we, you know, there's only one choice. So we haven't figured all that out yet. You have one more comment in the chat. You can see it on yours. Here.
So the question is, will there be anything new for the Python rule engine plugin? I mean, has PREP already had all these new features GenQuery2 will bring? For the GenQuery2, the entry point of the interface will be iQuery instead of iQuest. And will iQuest replace the iQuest? Will iQuery replace the iQuest, or will they together exist? All right, so this is, so far what you've seen me demonstrate in the demos is basically the experimental package. This is a project that right now is not available in the iRODS namespace, but will be very soon. And with this, the package that is produced by this will provide API plugins, as well as microservices, and possibly a new UI command that may not make it into it's just for demonstration purposes, right? And it would just be available for people if they're interested in trying to play around with the system. So because it will be provided as an API plugin, it means that any client can support it.
But work would have to be done in the Python rule engine plugin to be able to hit a different it's already in the server. So
If the microservices, once the microservices are available,
they're available in Python.
PREP will be able to invoke GenQuery.
Very good, very good.
Mustafa, does that answer your question?
What about, will language integrated GenQuery also take on some of this as well, or no?
That is likely far down the road right now, because that requires a change to the actual parser. Because
In the rule language, in the iRODS rule language.
in the rule language, that's right. So hence the reason why we have to implement microservices, so that it's just readily available. Not as convenient, but you know, it will be available.
Yeah, and we've got prototypes for that yet, but not ready for demo purposes. Coming soon. So then everything should be available to all the tools that we already have, kind of as a sidecar, And then the question is, well, how do we incorporate what we've learned when we're ready into the main stuff? Do we just replace it? That seems a bit bold, right? Probably we're gonna have to allow a flag or a selector of some kind for a while.
The other thing is that this is all opt-in, so you don't risk breaking your system, your deployment by installing this. Of course, don't install this in a production environment, but it will be available.